What is it like to read about the four great beasts of physics in one go? 1. Schrödinger's cat. This was a thought experiment proposed by physicist Schrödinger in relation to quantum mechanics. Imagine putting a cat into a sealed box along with an atomic device. If the atom decays, poisonous gas will be released and the cat will die. But whether the atom decays or not is uncertain. To know whether the cat is dead or alive, we must open the box. However, before opening, most people would think there are only two possibilities. The cat is alive or it is dead. But the peculiarity of quantum mechanics is that, as long as the box is unopened, we can never know the cat's fate. In this sense, the cat exists in a superposition of states, both dead and alive at the same time. This paradoxical state is what makes Schrödinger's cat so unique. If the reasoning is true, not just the cat, but everything in the universe that isn't being observed would also exist in a state of uncertainty. Thus, the principle of microscopic uncertainty extends to the macroscopic world. Objective laws exist independent of human perception. The idea of a cat being both alive and dead defies logical thinking. Yet as one of the four great beasts of physics, Schrödinger's cat has sparked immense debate and remains the most famous and controversial thought experiment. With the development of quantum physics, it has even given rise to concepts like parallel universes. Scholars have tried to prove multiverse theories through experiments, but so far only the randomness of quantum mechanics has been confirmed, not determinism. 2. Zeno's tortoise. Why can the fastest runner in the world not catch up with a tortoise? In ancient Greece, the hero Achilles, known for his running speed, raced against a tortoise. Suppose the tortoise crawls 1 meter in 5 seconds, while Achilles runs 10 meters per second. To make it fair, Achilles lets the tortoise start 100 meters ahead. Zeno argued that Achilles would never catch the tortoise. Why? Because by the time Achilles runs 100 meters, the tortoise has moved forward 10 meters. When Achilles covers that distance, the tortoise has again moved a bit further, and so on. Since time can be infinitely divided, Achilles would always be a step behind. This paradox seemed like wordplay, but actually questioned the very nature of time. Does a smallest unit of time exist? Thousands of years later, quantum mechanics answered this. The shortest time interval in the universe is Planck time, and the smallest length is Planck length. From this perspective, the tortoise cannot create infinite divisions. At some moment, Achilles will catch it within the limits of Planck time. In fact, Zeno's paradox indirectly opened the door to the concept of time machines and space-time travel. 3. Maxwell's demon. Could entropy and time be reversed? Physicist Maxwell proposed the idea of a tiny creature, later called Maxwell's demon, to challenge the second law of thermodynamics. Imagine a perfectly insulated container divided into 2 equal parts with a small door in between. Inside, gas molecules move randomly due to heat. Maxwell's demon stands at the door and can detect and control molecules. It lets slow-moving molecules pass to the left box and fast-moving ones to the right. Over time, one box becomes hotter than the other, creating a temperature difference spontaneously. This seems to violate the second law of thermodynamics, which says heat naturally flows from hot to cold, and that entropy, disorder, always increases. On a cosmic scale, the second law suggests that as energy diminishes, the universe will end in darkness and death. But if Maxwell's demon truly existed, entropy could be reversed, broken mirrors could be restored, and perpetual motion machines could be created. The universe could be reborn from decay. 4th, Laplace's demon all-knowing, all-powerful, capable of predicting the entire universe. In the early 19th century, physicist Laplace proposed the idea of a demon that knows the precise position and momentum of every atom in the universe. Using Newton's laws, it could calculate the past and future of everything. In this view, the universe is like a precise machine. Every particle, every planet, every life, all predetermined. A person's entire life, from birth to death, would already be decided. This led many at the time to despair, seeing Laplace's demon not as a divine beast but as a terrifying devil. It denied free will and implied total determinism. However, in the 20th century, Heisenberg's uncertainty principle in quantum mechanics shattered this notion. It showed that we can never know both the exact position and momentum of a particle at once. Later, chaos theory also contradicted strict determinism, proving the universe to be far less predictable than Laplace imagined. These four great beasts of physics, Schrödinger's cat, Zeno's tortoise, Maxwell's demon, and Laplace's demon, each challenge our